This is WAEC June 2020 General Mathematics Paper 2, and we are answering question number 7A. And the question reads, the diagram shows a wooden structure. This very diagram is a wooden structure composed of a cone that is mounted on a hemispherical base. The top part is a cone in nature, while the bottom part is hemisphere. The cone is now mounted on top of this hemispherical base. The vertical height of the cone is 48 meter. Look at it, 48 meter indicated in the drawing. That is the vertical height of the cone. And the base radius of that very cone is 14 meter. Look at it, 14, the base radius of the cone. And the question asked is calculate the correct three significant figures the surface area of this very structure. This is a very solid shape. We have to find it is a surface area. So let's attempt to answer this very question. The value of pi asked to use is 22/7. Solution to this very problem. What you do first is to go back to your drawing, analyze it completely. It is a cone on top of a hemisphere. Hemisphere is simply referring to half of a sphere. So what you write first is the formula for the total surface area, or for the surface area. The surface area of this very structure will now be the curved surface area of the cone plus the curved surface area of the hemisphere. That will give the formula pi RL, the curved surface area of the cone, plus the 2 pi r squared, the curved surface area of the hemisphere. So now check your drawing, see whether you have all those variables. The pi is given in the question, the radius is given in the question, and the L, the slant height of the cone, is missing. So what is required of you is now to find the slant height of this very cone. Then you can come back to this very formula and substitute. So finding the slant height of the cone, look at it. This is the slant height. I can now apply the Pythagoras theorem. I have this side 48. I have this side 14. This is a right angle triangle. So the slant height is now going to be square root of 48 square plus the 14 square. Getting 48 square and 14 square correctly and adding the two results gives answer 2,500. Square root of 2,500 correctly gives a result of 50 meters. So the slant height of this very cone is now going to be 50 meters. So I can come to this in my formula, substitute my pi, my r, and my l. There, if you done correctly, you will now have 22/7 for pi. Multiplied by 14, that is your r. Multiplied by 50, that is the slant height. This gives you the curved surface area of the cone. Then plus substituted in the second part of the formula that gives you the surface area, or rather the curved surface area of the hemisphere. So 2 multiplied by 22/7, your pi, multiplied by 14 square, that is this r square. The radius of your hemisphere will now be exactly the same as the base radius of your cone. So simplifying these two parts, you now have 2,200 for the curved surface area of the cone, and for the curved surface area of the hemisphere, you now have 1,232 if done correctly. Adding these two values correctly gives the surface area of the structure as 3,432 meters square. The question asks is to give this result correct to three significant figures. So this answer we need to change it to approximate it to three significant figures. That will give result 3,430 meters square. This would now be the surface area of this very structure. And that answered the question. So let me just share with you quickly the mark distribution for this very question as it is there in the marking scheme. So the very first mark is method 1 mark. And this method 1 mark is attempting to get the slant height of the cone by substituting the base radius and the vertical height using the Pythagoras theorem. You have this method 1 mark. When you now have this slant height exactly as 50 meters, you now have this accuracy 1 mark. When you now substitute your r, your l in the formula for finding curved surface area of the cone, that is the first part of this very formula, you have this method 1 mark. And when you now substitute your pi, your r in the second part of this very formula, that the one that gives you the surface area of the hemisphere, you have this method 1 mark. And when the curved surface area, you have it exactly as 2,200, you have this accuracy 1 mark. And when the surface area of the hemisphere, you have it as 1,232, exactly you have this accuracy 1 mark. Adding the two values correctly, you have this method 1 mark. And when you now added and rounded the answer to three significant figures, you have 3,430 meters square, you have this accuracy 1 mark. So if everything is done correctly in this very question, you have 8 good marks.